Section 9.4 Properties of Logarithms. Now that we know a little bit about logarithms, let's see what the rules are. So properties, that means the rules of logarithms. First property is called product rule. That means if the logorand is product of two numbers, you can split the log and write it as what? Summation of two logs. In other words, log of the first one plus the log of the second one. Okay, for instance, if I have, let's say, log of 5x base 3, I can split this based on this rule as write it as log of 5 base 3 plus log of x base 3. Notice I split the product into summation of two individual logs. That's called product rule. Log of 6 times 4 base 5, I can what? Split it as log of 6 base 5 plus log of 7 base 5. So if you have a product in the logorand, then you can split the log in terms of addition of two separate logs. Sometimes you do have the addition, so you want to go back to the what? Product form. Instead of going this way, sometimes you may have to go the other way around. For instance, what would be the log of 4 base 2 plus log of what? 5 base 2. Well, that would be log of what? That would be log of 4 times 5 base 2, which is log of 20 base 2. Log of x base 3 plus log of 2 base 3. Well, remember where summation comes from. It comes from product of these two logorands. So the answer is a single log, but the product of these two logorands, which is log of 2x base 3. The next rule is called quotient rule. And that's like, what if we have a fraction in the logorand, log of x divided by y base b, then that becomes subtraction, which is log of the what? Numerator base b minus log of the denominator base b. For example, if they ask me to simplify log of 19 over 4 base 3, that would be log of 19 base 3 minus log of 4 base 3. Remember, numerator goes first, followed by denominator. Log of x base 3 base, log of x over 3 base 6 is log of x base 6 minus log of 3 base 6. Remember, sometimes we can either go from this form to that form or back to the single log. In other words, if I have subtraction between two logs, I can write it as a single log, provided I divide the first logorand by the second logorand, which is 15 over 5. So the simplified form of this subtraction is log of 3 base 4. Log of x base 8 minus log of 2 base 8 is just simply log of x divided by 2. Divide this logorand by this guy and write it as a single log. Keep the base the same. Okay, rule number 3, it's called power rule, correct? So this is called power rule, which says if the logorand has a power, the power can be liberated and you can rewrite it next to the log in what? Multiplication form. What does that mean? If I'm asked to simplify log of 4 to the power of 3 base 2, so the 3 goes right next to the log and it appears in multiplication form. So log of 4 to the power of 3 base 2, now it's the same as 3 times log of 4 base 2. Log of x to the power of 3 base 6 is 3 times log of x base 6. Log of the square root of x base 5 equals log of x to the power of 1/2. Remember, square root of x is exactly the same as x to the power of 1/2. Remember section 7.2, where you can write what? Radicals in terms of what? Exponents with rational powers. So the 1/2, what? You can liberate the 1/2 and write it next to the log. So this would be 1/2 times log of x base 5. Okay, sometimes you may have a number next to the log, so you have to put it back where it came from. So here, if they ask me to simplify this, I'm just going to write that as log of x to the power of 5 base 2, because this 5 must have come from the power of the logorand. Negative 3 times log of 2 base 4, you can just take negative 3 and put it back where it came from, which is the power of the what? 2. So this would read log of 2 to the power of negative 3 base 4. 1/6 times log of 7 base 9, you can take 1 over 6 and place it on top of the logorand as a power. Okay, rule number 4. Anytime the logorand is 1, regardless of what basis, the answer is 0. For instance, log of 1 base 5 is 0. Log of 1 base 2/3 is 0. As long as the logorand is 1, regardless of what the base is, the answer is 0. So that's rule number what? 4. Okay. Rule number 5. If the logorand matches the base, then the answer is 1. For instance, log of 7 base 7 is 1. Log of 11 base 11 is 1. Log of 5 base 5 is 1. Log of 10 base 10 is 1. Rule number 6. B to the power of log of x base b. If the power of the log matches with the base here, the number you're trying to raise the log to, so the answer is always the logorand. For instance, if someone says, hey, what is 7 to the power of log of 3 base 7? Notice these two numbers match, so the answer is just 3. 1/3 to the power of log of 8 base 1/3. Notice these numbers match, so the answer is 8. 10 to the power of log of 12 base 10. Notice these numbers match, so the answer is 12. Finally, rule number 7, which is called conversion of bases formula. This is like when you want to what? Change what? The base of the log from one base to another base. Okay, so the formula goes log of x base c. Let's say you want to change that c to base b. The rule is you take log of x base b divided by log of c base b. In other words, suppose I was asked to do this on my scientific calculator. By the way, this log key, which you see right here, has base 10. So you cannot use any other base except base 10. Okay, for instance, what if I was asked to do log of, let's say 5. So this is like automatically what? A built-in base 10. You don't see the 10. The minute you push this log key on your calculator, the assumption is the base is 10 if you enter. So the answer is 0.6990. How about log of, let's say, oh, I don't know, 0.3. The answer is negative 0.5229. Notice what happens if I go log of 0, undefined. How about log of, let's say, negative 4? Okay. All right. So negative 4, undefined. Why? Because the logorand cannot be 0 nor negative, correct? So what if someone asks you to evaluate log of 11 base 13? Well, this log key doesn't, it has a base 10. So what you have to do, you have to use this formula to change the base to 10, and then you can use your scientific calculator. According to this formula, log of 11 base 13 is log of 11 base 10 divided by log of 13 base 10. So let me just show you how that's done. So this would be parentheses, log of 11, close the parentheses, divided by, open parentheses, log of 13. And the answer, folks, is 0.9349. So it's 0.9349. Do you see it? So I had to change the base from 13 to 10 so I can use my calculator, because this log key has a built-in base 10. What about they ask me to evaluate log of 9 base 3? Well, first I use this conversion formula to change it to base 10 so I can use my calculator. So log of 9 base 3 is log of 9 base 10 divided by log of 3 base 10. So how do you do that? Well, you kind of go parentheses, log of 9, close the parentheses, divided by, open a parentheses, log of 3, close the parentheses. So the answer is just 2.000. There you go. You all see it? So sometimes they might ask you to what? Expand the expression using what? The rules of logs. Notice division of the logorand comes from subtraction. I believe that was quotient rule, so I can simplify this as log of 13 base 7 minus log of 31 base 7. Same thing here. This is division, so you have to split it into what? Subtraction of 2 logs. Do you see it? Okay. This guy has a power, so power rule says place the 5 next to the log, like so. So this would be log of what? 5 times log of x plus 7 base 4. Division comes from subtraction, so that's log of 9x base 10 plus log of 8y base 10. But wait a minute, there is a multiplication here, so the product rule applies. So that's log of 9 base 10 plus log of x base 10. I can apply the product rule for 8 times y. So that would be log of 8 times 8 base 10 plus log of what? Y base 10. So this is what they mean by expand. Expand means what? Pull it apart. So break it up. Okay. Sometimes the problem shows up as what? Expansion form, but they want you to write it as a single log. Remember, addition comes from product of the logorands. I believe that was using the product rule backwards. So this is log of 4 times 3 base 7, which is simply log of what? 12, is that right? Base 7. Subtraction comes from division of the logorands. So this would be log of just 17 over 3 base 7. Okay, this guy, remember 1/3 has to go back where it came from, which is the power of the logorand. So that will be 1/3 base 8. To simplify this guy, first I have to put 2 where it came from. So this would be log of x squared base 9 minus log of y minus 2 base 9. But remember, subtraction comes from division of the logorands. So this is log of x squared, what? Over y minus 2 base 9. Here, first I gotta do the what? Don't worry about the 2. Do what's inside the parentheses. Remember, subtraction comes from division of the logorands. So this should be log of what? X over 5 base 3. Is that right? So there is no need for parentheses. But remember where 2 came from. It must have come from the power of the logorand. So put it back where it came from. So this would be log of x over 5 squared base 3. And that's pretty much how you use the rules to either what? Expand the logarithmic expressions or write them as a single log. Thank you.